Hi and welcome to SYS Systems. I'm Rob Thompson, the Sales Manager here at SYS, and today I've got Matt Jones, Senior Applications Engineer from Stratasys with us, and in this video we're going to talk a little bit more about the SAF process, which is a proprietary process developed by Stratasys, and it's a powder-based 3D printing process. So Matt, do you want to give us a bit more information about SAF?
Yeah, so we have the H350, so Selection, Absorption, Fusion, which is what SAF stands for. And basically we're using powder, so PA11, nylon 11 powder with a single absorption fluid to basically print your parts. But it's not aimed at sort of low volume or prototyping. It's really aimed at mass manufacturing large volumes of components that you may need.
Right, okay, so people will be used to perhaps having parts maybe printed in a powder-based technology, maybe an SLS style print from a service provider or something like that. Where does this differ from other powder-based technologies?
So other powder-based technologies have multiple fluids, so we just have the one fluid, so the running costs are much lower. It's also recyclability of the powder, so it's 70% of it is basically the old powder that's being reused. And then we have the sledge on top. So basically we move in one unit direction. We don't go one way and then the other way. So it's much quicker and repeatable. We have much tighter tolerances with regards to the controls on the temperature inside, which is key for the powder-based processes. So we suffer very little from sort of surface defects on there, depending on the nesting densities and things, which also we have the highest nesting density possible as well. So it's although maybe a slightly smaller build volume than some of our competitors out there, you're actually cramming a lot more parts in the build bed over a sort of 18-hour period to get a full stack out of the machine.
Superb. So again, this technology is really aimed at the throughput, the quantity of parts that you can get through accurately, repeatably into a production environment with some of these material properties that we've got now. Then.
Exactly. PA11, it's a phenomenal material. There are other materials on the roadmap like PA12 and PP materials that will be coming out later. But really the whole crux of it is if you need that low volume manufacturing. When we say low volume, it's still tens and tens of thousands of parts where it doesn't make sense to go down the tooling route, or there's so many design changes or little tweaks on different parts where it makes sense to come off. Obviously, you can see when it comes off the machine, it's like this grey colour that you get off the machine. There's loads of post-processing techniques out there. One of the main ones is from a company called Dimension, where you can use different surface treatments to get better surface quality, dye them black, pink, purple, whatever your preference you can do for whatever your product may be. Fully working hinges, springs, all possible on the machine in one go as well.
Superb. So what types of businesses would you be saying at the minute you're seeing take this kind of technology on and use it in their applications?
Electronics, massive one. Automotive, some aerospace as well. Also for sort of orthotics for shoes, soles and things like that as well.
Okay,
so it's a good application.
Mass customization then, where you've got maybe multiple parts to print that are very slightly different. This would be a good technology for that.
Yeah, very good. Or just the same part over and over again. There's a case study about the Ukraine war at the moment with all the tourniquets that have been done in SAF as well. So, where you need massive volume or you need to increase production because you can't cope with the amount of orders that you've got coming in. Okay. You can go down this route too.
Perfect. So it's, again, reducing that requirement for tooling, allowing people to redesign the part slightly for the process as well to get absolute key part quality out and accuracy, but also the fact that you can scale this up. A lot of people with multiple machines now.
Not just one. So people tend to buy one and then they start ramping it up. It soon becomes 2, 3, 5 and so on, because the volume of parts and the total cost per part is extremely low compared to FDM or even P3, for example. The cost per part, as long as the material, the PA11 is suitable for whatever it is you're doing, it's a lot cheaper. Yes, your initial investment's higher, but your total cost of ownership is lower over the period of the years you use the machine.
Fantastic. And we've seen quite a range of companies investing in the H350, all the way from OEMs who might be looking to reduce down tooling costs on a build of a particular piece of machinery, like special purpose machinery, maybe where you're making 10 or 12 off of a high value piece of machinery, and actually being able to take some of those metal components or even plastic components where you're having to tool up and produce those all within one build on the SAF.
Exactly that,
machine.
Exactly.
It's really a great technology for that. So if you've got any applications where you think the powder-based SAF technology and the H350 system might be suitable for you, please do get in touch with us. We can take one of your parts, we can assess that. Matt, I'm sure, will be happy to get involved as well, and we can really make a case for seeing if having a H350 on site would save you a huge amount of time and money in production.